Hello everyone, I'm Kenny from Noble. I will share with you injection molding process. Hi, welcome. The injection molding process mainly includes 6 stages: mold closing, filling, pressure holding, cooling, mold opening, mold release. There are 6 stages directly determine the molding quality of the product, and there are completed continuous process. This chapter focuses on the 4th stage of filling, holding pressure, cooling, and mold release. About the filling stage, filling is the step in the injection cycle, and the time is calculated from the beginning of the injection mold closure to the filling of the mold cavity to about 95%. In theory, the shorter the filling time, the higher the molding efficiency. However, in actual production, the molding time or injection molding speed is subject to many conditions. About high-speed filling, when filling at high speed, the shear rate is high and the viscosity of plastic decreases due to the thinning, which reduces to overall flow resistance. Local viscous heating effects can also then be solidified layer. Therefore, in the follow control stage, the filling behavior often depends on the volume to be filled, that is, in the flow control stage, due to high-speed filling, the shear thinning effect of the metal is often large, and the cooling effect of the thin wall is not obvious, so the rate effect prevails. Filling at low speed, the shear rate is low, the local viscosity is higher, and the flow resistance is larger when filling at low speeds controlled by heat conduction, because the hot plastic supplement rate is low and the flow is low, so that the heat conduction effect is more obvious and heat is quickly taken away for the cold mold wall, coupled with a small amount of viscous heating situation. The thickness of the solidified layer is thicker, and the follow resistance at the center part of the wall is further increased. Due to the flow of the fountain, the plastic polymer chains in front of the flow wave are aligned almost parallel to the flow wave front. Therefore, when the two strands of plastic meet and the polymer chains of the contact surface are parallel to each other. In addition, the properties of two strands of metal chips are different in the mold cavity. Temperature and pressure are different, resulting in poor structural strength in the fusion area when the parts are placed at a right angle under the light and observed with the naked eye. It can be found that there can obviously join line, which is the formation mechanism of the weld mark. The weld mark not only affects the appearance of the plastic parts, but also its mechanical construction is low, which is easy to cause stress constriction, so that the strength of the part is reduced and fracture occurs. Generally speaking, the strength of the weld marks generated in the high temperature zone is better, because activity of polymer chains is relatively good high temperature, it can penetrate and intervene with each other. In addition, the temperature of the two mass strengths in the high temperature region is relatively close, and the thermal properties of the metal are almost the same, which increase the strength of welding region. On the contrary, in the low temperature area, the welding strength is low. Pressure holding stage. The role of the pressure holding stage is continuously apply pressure, convex and metal and increase the density of the plastic to compensate for shrinkage behavior of the plastic. During the pressure holding process, the back pressure is higher because the mold cavity has been filled with plastic. In the process of retaining pressure, the screw of the injection molding machine can only slow moving forward slightly, and the flow speed of the plastic is also relatively slow, and the flow is called retaining pressure flow because in the pressure holding stage, the plastic is closed and solidified faster by the mold wall, and the metal viscosity increases quickly, so the resistance in the mold cavity is very large. In the later stage of pressure holding, the material densities continues to increase, and the plastic parts are gradually formed. The pressure holding stage should continue until the gate is cooled and sealed, and the cavity pressure in the pressure holding stage reaches the highest value. At the pressure holding stage, the plastic exhibits partially compensation characteristics due to the high pressure. In the high pressure area, the plastic is more dense and the density is higher. In the lower pressure area, the plastic is more loose and less dense, so the density distribution compensative changes with location and time. During the pressure holding process, the flow rate of plastic is very low, and the flow no longer plays a leading role. Pressure is the main factor affecting the pressure retaining process. During the pressure holding process, the plastic has filled mold cavity and gradually solidified. Metal acts as the medium for transforming pressure. The pressure is the mold cavity is transformed to the surface of the mold wall by means of the plastic, which tends to open and mold, so the mold is locked by right clamping force. Under normal conditions, the expansion force will slightly push the mold part, which is helpful for the exhaust of the mold. However, if the expansion force is too large, it's easy to cause the raw edge of the molding product overflow and even open the mold. Therefore, welding selecting an injection molding machine with a large enough clamping force should be selected to prevent the situation of the mold expansion and efficiently maintain pressure. On the new injection molding environmental conditions, we need to consider some new injection molding process such as gas-assisted molding, water-assisted molding, foam injection molding, and so on. About the cooling stage, injection molding molds. The design of the cooling system is very important. This is because the mass of the plastic products can only be cooled and solidified to certain rigidity, and the plastic products can be prevented from deformation due to external force after demolding. since the cooling time amounts for about 70% to 80% of the entire molding cycle. A well-designed cooling system can significantly shorten the molding time, improve injection molding productivity, and reduce costs. Improper design of the cooling system will elongate the molding time and increase the cost. Uneven cooling will further cause rapid deformation of plastic products. According to the experiment, the heat from the metal into the mold is roughly dissipated in two parts, one of which 5% is transformed to the atmosphere by radiation and convection, and the remaining 95% is transmitted from the metal to the mold. Due to the role of the cooling water pipe in the mold, the heat is transformed from the plastic in the mold cavity to the cooling water pipe through the heat conduction through the molding frame, and then taken away by the cooling liquid through the heat convection. A small amount of the heat is not taken away by the cooling water, continues to conduct in the mold and spills into the air after contact with outside board. There are some factors that affect the cooling rate of the product. Plastic product design. Many plastic products wall thickness. The greater the thickness of the product, the longer the cooling time. In general, the cooling time is about proportional of the square of the thickness of the plastic products, or proportional to the 1.6 square of the maximum runner diameter, that is, the thickness of plastic products is doubled, and the cooling time is increased by 4 times. Mold material and cooling method. Therefore, mold materials including mold core, cavity material, and mold frame curtain have a great influence on the cooling rate. The higher the thermal conductivity of the mold material, the better the effect of the transforming heat from the plastic per unit time, and the shorter the cooling time. Cooling water pipe configuration mode. The closer the cooling water pipe. Hello, dear friends. The closer the cooling water pipe is to the mold cavity, the larger the pipe diameter and the more the number, the better the cooling effect and the shorter the cooling time. Coolant flow rate. The greater the flow of cooling water generated to achieve the turbulent flow is best, but